Hey students, welcome to video 5B. We're going to talk about some types of clamps. This is by no means exhaustive, but this is just some of the types of clamps that you may encounter. We'll have some more when we have the in-class portion, but I wanted to start off with this just to introduce you to some different types of clamps that you may see. So let's get right to it. Okay, so if we have our part here that we've been working on and we want to clamp this in place, how do we do it? Well, remember we'd like to clamp downwards, and there are all kinds of things that we can use to clamp downwards. So one of them, is this. So this is called the toggle clamp, and you can see that as I move this handle, the part would be clamped in place by this surface right here, and so that surface comes down and it gets locked into place. Another kind of toggle clamp is one that provides a sideways force. So this one you can see has a handle, and as I push forward, the piston pushes out. So I could put this on the side of the part and push inward to clamp it against the two locators on the opposite side. So some things about toggle clamps. Toggle clamps are really good in low force applications. So if I were doing welding, or if I were positioning something to assemble it and I didn't have to put a huge amount of torque on it to assemble it, a toggle clamp is really good. But because they're made of sheet metal and they're riveted together like this, they're not super rigid, nor, you can see, because it's all sheet metal, it's not incredibly rigid just in the body of the clamp. And so in general, these are not good for machining type forces. They're great for inspection, they're great for assembly kinds of things. What are some other ways that I could hold a part in place? Well, we always talk about pushing, but what about pulling a part into place? There's a giant suction cup, and there's some other suction cups. So that's another way that I can hold a part in place. So I could turn this around for a minute, and if I had enough area here, I could put a suction cup, and that would pull the part against these two locators. Now, if I were going to do that, that's only for really low force activities. It works well for sheet metal and positioning parts for assembly, but not for a whole lot else, just because it's not very strong. What if I want to do some machining? Well, you used a vise in lab, and so a vise is a good way to hold something. It's very universal, it's very easily adjustable. It has some challenges otherwise. But I want to introduce you to another set of things. These are called Mighty Bites. And so that is a trade name. And you can see the Mighty Bite on its side right here. And you can see two of them installed down here. And the way that these work, if we look at the shape of it, it's a little hard to get it to be in focus, but anyway, if we look at the shape of it, it has a big slot in here, and so this top part can rotate back and forth on the screw. And so what happens is you put the part in place, and as you tighten it in, the Mighty Bite jams against this back wall of the pocket that it's in, and it leans forward and grabs the part, and it both pushes in against that locator and pulls down. It kind of bites into the part and pulls it down. And in fact, you can get Mighty Bites that have a smooth edge or Mighty Bites that have a very sharp edge on them, depending on whether you can indent your part or not. The ones with the sharp edge will hold it a little bit more tightly. And then we just clamp the part in place, and it keeps it from moving. And this one, if you look at it, you can see that this is sort of set up to be tension pulled. And so one thing that we did last year was we clamped it, and then we put it in the tension testing machine to see how much force we could put on this before we were able to pull this part out of this clamping system with two Mighty Bites. Now, is this obeying all of our rules? Remember, one of our rules at the very beginning was we're going to assume that there's no tension or no friction. Well, no, it's not obeying that rule, because if we were going to obey the friction rule, we would have to have something that would be pushing this down against the back surface, and in fact we'd have to be pushing on the end here to keep it from separating from this edge right down here. But in fact we are depending on friction, so we are applying a force inward, we're applying a force downward from these mighty bites, and we are assuming in this system that all the other directions of motion will be limited. Is that a good assumption? Well, against a relatively low force, it's fine. I don't know how much force it would take to rip this up out of here. These are pretty small, so it's probably on the order of 700 or 800 pounds would rip this part out of here, but that's a pretty significant amount of force for something that's this tiny. Is it very good at preventing this part from sliding this way? And the answer is no, because this is pressing a smooth-sided part against a very smooth-sided dowel pin, and so there's very poor friction over on this side, and so motion in the shear direction, pulling this part outward in this direction, is relatively easy to do, so it's not a good fixturing method for that direction. But mighty bites are really easy to use, and look how low profile they are. They're way down in there, so if I want to do a bunch of machining up here, I can do that without fear of hitting those parts. And I could make these locating pins shorter as well. Another idea that came from the Mighty Bite company once they started working on mighty bites was this kind of toe clamp. So looking at these from the side, what happens is a part is held, here's a part, you take a part, and so it is held on top of these steps. And so let me set this up a little bit. I would have these two. In this system, this is acting as a locator. Also, this surface right here is a locating surface. Same on this one, this locating surface, the flat right here, and then I have the clamp on the side. And the way that this works is, you'll notice by looking at that screw hole, it's a little difficult to see because it's black on black, but the hole there is not concentric with the head, and in fact the whole screw looks, whoops, it ran away. This is a smaller version of it, but the whole screw looks like this. You can kind of see that the head of that screw is not concentric with the body. As I rotate it, you can see the head wobbles from side to side. So the way that this kind of clamp works is that you would put it in place, and then when you turn this head, because or you turn this screw, because the head is eccentric, it will push the clamp over into the part. It is at an angle, so it pushes some down force on it. You can get these serrated and not serrated. The serrated ones will damage the part, and the non-serrated ones will not damage the part, but unsurprisingly, the serrated ones have a much higher holding force. So this is another method for being able to clamp parts in place. And then sort of one last set, I think, of ways to hold parts in place is this. So this is called an expandable bushing, or an expandable collet. And so this is for locating something on the inside of a bore. So if I had this part and I wanted to use this bore here as a locating device, this is both a locator and a clamp. So the way that this works is it has these cuts down the side, and so as you tighten this bolt, the inside is shaped as a cone, and so the tighter I tighten that bolt, the more that these leaves here on the outside expand outward. And so if I put this on and then tighten that bolt, it will expand outward equally in each direction, so that's why it's a reasonable locator, and then it will also clamp it in place. Not a really good clamp against vertical motion, and you can overpower them in the twisting direction, but it does a very good job of eliminating XY motion, a pretty good job of Z motion, and then I would need to get another way to clock this and prevent it from rotating, because this is not a very good way to do it. Because this is also expandable, well, yeah, let's not go there. Anyway, so those are just a few different ways that you can clamp things that are outside of what we've seen in the classes. So certainly vices are another way, and then there are all kinds of hybrids. There are vices where these mighty bite parts are on top, or talon grips is what they called then, are on top of the vise, and so you can use those to grab a part just on a little tiny bit of the edge of the part, but still using a vise kind of system. And there are many, many, many other types of clamps that are out there. We will look at some in class, but I just wanted to give you an idea of a number of sort of different ones that maybe you hadn't seen or dealt with or thought about very much that we need to be able to think about in this class. All right, hope you enjoyed that, and I will see you in the synchronous portion together. Bye.